I wanted to show you the final configuration of what we'll be talking about today. Don't worry, we'll step through this piece by piece and I'll show you how this is put together. But let me show you the amazing thing I was able to do with a relay. What I have here is a fan that runs on 12 volts direct current, DC 12 volts, runs off a battery, and that's how it will usually run. And that's easy enough to wire up. But here's the interesting requirement. When the battery runs low, I want to be able to walk up, plug it in, and I want the fan to continue to run with practically no interruption from this power supply. Also, at the same time, I want this trickle charge to fire up and start charging the battery. Meanwhile, the fan is running as if nothing had happened. And when the battery gets all charged up, I want to disconnect and go back to running off the battery again, powering down the power supply and the trickle charge. Kind of on top of that, to complicate matters, I had a concern that there's parasitic current draw both from the power supply and the trickle charge, in that I didn't want the battery to be, I didn't want these two items to continue to be connected to the circuitry. I was afraid that they would draw current, even though they're powered off. Just the circuitry might draw power from the battery. Maybe I'm imagining that. But anyway, the relay takes care of that for me. It disconnects the power supply and the trickle charge whenever it's unplugged here. So let me show you the magic of relays and how I was able to implement it for this project. Incidentally, let me show you how it works. Right now it is running off the battery. Here's a little piece of thread to show you the fan is running. Listen closely, you can often hear the relay click. Listen. And there's only a half a second interruption and the fan is still blowing, now off the power supply. And the trickle charge is now charging the battery. I didn't have to flip a switch or change any wiring. It's all automatic due to this $4.50 relay. And we can go back the other way now. I can disconnect. And the fan is blowing away. It's a little weaker. I can tell the battery needs to be charged up. But otherwise, everything's working great. It was easy to do. Let me show you how we did it. So in our case, we are going to hook up the battery power. Now keep in mind the negative side of the battery will be permanently connected to the negative side of the fan, and there's no need for this to go through the relay. But for the positive part of the battery, we're going to connect it to the common, which is at the top of the triplet terminals here, and we'll have it coming off the normally closed here, because we want, when there's no power, we want the battery to always be on. So we want the other lead coming off here will be the normally closed. And here's a better view of it. Again, we'll have our power terminals up here. They're grayed out, showing that they're not powered on. But we're going to connect our battery common, and we're going to connect it, and we're not connecting it to that one. We're connecting it to there. We'll be doing quite a bit of editing, I do believe. So this is what we're going to connect. We'll eventually connect up our AC 110 volt terminals here. But right now we're going to connect our battery terminal to the common, and we'll have the remainder of that continuity coming off the NC. What does NC stand for? Normally closed, that's right. So common and then normally closed. So that's a little bit more clear. So here's the battery terminal coming off, and so it's going to go right here to the common on this side, on this pole here. Incidentally, I think it's cool that these relays, at least this one, comes with terminals that fit the standard spade terminal. This is I think it's a number 10. It's a 6.3 millimeter wide female spade side of a terminal, and it fits these terminals real well. And it also has holes. If you don't have these and you just want to wire it, you could put a wire through there, do a touch solder, and you can do it that way too. But this is very convenient, I think, that we got that connection with the terminal. So this is the common, and then to the fan we'll connect to the normally closed, which is here. So right now I can tell you without power here, these are connected. And so if we were to hook up the battery power, we would actually, the fan would start running right here. So now let me go ahead and connect up the AC connection side. And so this is 120 volt AC. That's the common side, and here's the live wire. It turns out this particular relay, it says polarity here is not required. So we could have reversed these wires. It just doesn't matter. Detection terminals will be hooked up to the AC. Now this is the only time on this relay that you will hook up a negative and a positive charge. Don't do that on these terminals here. These are specifically only for continuity. You're going to have a wire that's going to either have a disconnect, or it's going to be closed, open or closed. You don't want to start sending in charge from negative to positive to this thing. These are the only ones, and the way this relay is going to work for this project is it's going to detect whether or not somebody has plugged in the AC. Okay, this is the simplest setup. We have our AC plug is not plugged in, that goes to these terminals right here. We have our battery connections here. Battery's not connected yet. The negative wire from the battery goes directly to the fan. It will always be connected without going through the relay. There's no need. However, the positive side is going to go through the relay, and it's going to go through the normally closed. We want a complete circuit. We want a closed circuit. And so I'm going to connect it here, meaning that as long as there's no power to these detection terminals, this common positive wire that goes to the common terminal on this pole will be connected. And so let's check it out. Let's connect the negative side, and here's the positive, and our fan is blowing away. So that's the first step, and that's the first use of our relay. If I were to plug it in right now, even though the AC doesn't do anything other than goes into the relay, the fan should stop. And let's do that. Let's check it out. So here we go. The fan's running. Now when I plug it in, that will, the charge, the 120 volt AC charge will go into the coil terminals, which I'm calling the detection terminals. It doesn't power anything. It just triggers the relay. And you can hear the click, and the fan is stopped, and that's because this is now it was normally closed, it's now open. This is now an open circuit between the common terminal and this far forward terminal. There's another terminal in between them, and that's the normally closed, is that right? Normally open terminal. So anyway, looks like it's working so far, so I'm going to unplug it, and let's put on our next step. Oh, I will turn off the fan. Now our next step is to power up the fan using a power supply. When I connect the AC, we know that this will stop the battery power. We saw that happen just now. the next phase of this build project is we're going to put in a power supply that's going to convert the 120 volt AC to 12 volt DC, and that 12 volt DC will run the fan. So we'll eventually get it to where when the plug is unplugged, it runs off the battery, the fan runs off the battery, and when it's plugged in, the battery's turned off, but it immediately starts running from the power supply. So let's see if we can do that. Here's the last of it. So we now have the power supply. The power supply is now connected directly to the AC. Now we have our 12 volt negative and 12 volt positive. Now the negative will be hooked up directly to the fan. It's the same as the battery. Negative is always connected directly to the fan. Similarly, we can connect the negative permanently to the fan here. Okay, we now want to hook up the power supply. The power supply it's hardwired directly to the 120 volts, and so it will power on when the entire device is plugged in. Okay, so the 12 volt positive coming off the power supply will be the common on this post right here. So it fits right there. So that's the source. And now the positive going to the fan, we want it to normally be open. We normally want things to run off the battery. So when there's no power, we want this to be open. And this is the normally open terminal for this side. Oops, this came off. So when the plug is unplugged, there is no connection, no power from the power supply. When it does connect, when the AC is connected, the coil is flipped, and this is now a closed circuit, and this powers the fan. At the same time, it's disconnected here. Let me show you the schematic here. So this is what we have. We have our detection terminals here, which do not have power, so we are powered through with the battery here. Over here, this is open, and so there's no power coming from the power supply. However, as soon as we plug it in, we power up the power supply. The battery flips from normally closed to open, so the battery's disconnected. The power supply now powers the fan. So let's go ahead and demonstrate that. The positive side of the 12 volt DC coming off the power supply will be going to the relay. And now we need the normally open connection right here. It will be closed when it's plugged in, see? So in the middle terminal, this is the normally open, and it's going to go to our connection right here, and I'll screw that in. And so now we have this connected such that as soon as we plug it in, the power supply works, the fan should run. When we unplug it, the power supply is turned off automatically because that's the source of the power. But the fan will automatically kick in because you'll hear that relay click and change it over to where the battery will work. Let's check it out. Okay, we now have this all connected to where, and just to clarify things, I'm going to not plug in the battery so we can just check out the power supply side. Right now, since it's unplugged, the power supply is turned off and there's no other source of power for the fan, so it's just sitting there. But as soon as I plug it in, we should hear the relay click. It should close the circuit for the normally closed, which is this wire right here in the middle, and it should power the fan because from the power supply. Listen close to the relay. You hear that click? The power supply came on because I plugged it in, it's hardwired. But the relay clicked over and now it's running the fan. And you know what? I can now connect the battery because there's no connection here. Since we're plugged in, the normally closed position here on the outside is now open. But listen close, I'm going to unplug it. We should hear the click of the relay as it goes back to the normal position, unpowered, and the battery will kick in. We should not see hardly any interruption at the fan here. Let's see if we notice anything. Okay, here we go. Okay, I heard it. I don't know if the camera picked it up. But the fan's still running. There's no power to the power supply. The light went out. And the battery is running right now. To me, this is magical. I didn't really know how relays work. This is my first relay project. And that's really great because, again, it saves a person from pushing any buttons or making a mistake and have two sources of power to a fan that could burn it up. It's a really neat device, and I'm excited that I've learned about relays. We're going to add another aspect to this just to make it more chaotic. We're going to add a trickle charge. While it's in this configuration, the battery's running. So I want that trickle charge to be disconnected from the battery. Technically, I guess you could leave a trickle charge connected all the time, whether the battery is running or not. However, I have a fear of parasitic current draw from devices that aren't plugged in and not doing anything, but as long as it's wired in to the battery, perhaps the battery is keeping some components warm, or there's some completed circuit within that device that we just don't see any light or heat or anything. And I'm just afraid. I want to save as much power for the battery such that the only power the battery uses is going to the fan. And since we have the relay, we're going to have this trickle charge disconnect from the battery whenever the battery's running. Now when it's connected like this, oh, you heard it. It took a little while for that to kick on. When the AC power is connected, we want that trickle charge to be connected to the battery and to start charging. So let's get that connected. Okay, here's our trickle charge. It's very small. I personally bought a small one so I can fit and not be in the way. First thing we're going to do is, see, we're plugged in. I'll have to remember not to work on it while it's plugged in. So the first thing we're going to do is connect the trickle charge directly to the AC power. And of course, again, there's no need for this side of the trickle charge to go through the relay, because when it's plugged in, I want the charger to be fired up and working. And when it's unplugged here at the AC plug, I want this to be turned off, so there's no need to go through the relay here. And it's still running, so we got to disconnect the battery. It's a little confusing that you have to disconnect two different power sources now before you start working on this. Okay, so I don't think the polarity means anything. And positive for this plug is the black side, so let me get a screw for that. We'll screw that in. And the blue wire here we'll put on the common here. So our trickle charge is here. On this side, I cut off the battery clips Instead, we're going to hardwire it in. The black wire is the negative DC side, the 12-volt DC charging side. It will be permanently connected to the negative side of the battery. Now, if the other side is not powered, it shouldn't have anything to do, and it should be ineffective and not have anything to do with the battery. It's just sitting there. So that's part of it. Now, if we were charging this battery, we would want this clip to the positive side. Well, the positive side goes to here, but we don't want to permanently connect it to the positive side because I want it disconnected when the battery's running. So it turns out we already got that connection. We can connect to the battery at the common, and we can use this unused, normally open plug right here. So now the battery, normally open, meaning there's no charge and the battery's running. Is that right? It's normally open. So it's open. So when the battery's running, and let's go ahead and do it. So when the battery's running, that middle terminal is normally open. Remember, our ohm meters proved that between the common, which is the positive coming from the battery, that's our common for this post. When this is unplugged, when the coil is unpowered, this middle position is open. So this charger is not connected to the battery. It's not doing anything. It's not powered, and it's not even connected to the battery. So it's just sitting there. But now, when we connect and run the fan on AC power, the power supply comes on and powers the fan, which is always done that. But here's an additional benefit. I see the little light turned on. This trickle charge is working, and I know that it is now closed here. There's a connection between this red wire and the common wire, which is going to the battery. And we know that we took the black wire and it's connected to the other side of the battery. So we are now charging the battery, and the battery's not running anything. So meanwhile, my fan is running away. So here we are at the final configuration, and again, it's due to the magic of a very cheap $4.50 double pole, double throw relay. And it's a new tool in my toolbox, and in the future for other projects, I will definitely be using relays to solve any logical electronic issues like this. I hope this has been helpful to your understanding of relays. Again, I'm over enthusiastic. I'm like somebody who's never seen a light bulb and wants to do a YouTube video of how a light switch will make it go on and off. I'm sure many electrical engineers and technicians are like, we use relays all the time, what's the big deal? But to me, they're really neat, and I just wanted to show my enthusiasm by showing you how I understood them. If you have any comments, or especially having corrections, if I showed anything wrong or dangerous, I know there's a little danger with these open terminals here, but anything more serious than that, y'all be sure to put comments and let me know about them. Thanks a lot. Oh, a little bonus video here. I've got everything unplugged. I'm not only doing this to show y'all, but to remind myself. I've got it unplugged at the AC. I've got it unplugged from the battery. I'm going to switch over, and before I just had shorted out these two posts for the positive side, but I'm going to go ahead and connect it up so I can read the amps coming off. Now I know you can do an induction circular thing with the, and I got one, but this just looks cool. I built this little portable ammeter. So I got a post here and a post over here, and it'll read the amps up to 30 amp maximum. So I'm going to read the amps across the terminal here, and just to see what the difference is between the power supply and the battery. And when I have multiple different batteries, or over time, I can see how much amperage I've lost. The other one goes way over here. Now, just to let you know, I built this so that it have an on-off switch if I wanted to turn something off and on for safety reasons or for whatever else. I also put a fuse in here. It's got like a 10 amp fuse to keep it from blowing out or ruining my meter. Now, incidentally, this is a question I have for you guys, and if you're knowledgeable, don't guess, but if you know, I'd appreciate your response. I can purchase amp meters that are just standalone meters. This one came with a shunt, big piece of metal, and this is what I understand. The shunt has a fairly low ohms but it's calibrated. They know exactly how many ohms are from here to here, and so the ammeter reads across this shunt. But this is what I understand. This is what I'm guessing, I guess. The shunt is really what's carrying most of the current. So you don't have most of the current going through the ammeter. It's really going through, from here to here, it's going through this shunt. And I can see benefits, one being you don't blow out your meter, perhaps. And is that why we have a shunt? To keep from ruining your meter? If we were to go beyond 30 amps, would it protect? Would the shunt keep you from ruining your meter? Is that part of it, or is it to keep a steady current draw and you don't affect your electronics by the meter itself causing a change in the amps? I don't know. Somebody help me out there. Anyway, what we're going to do, oh, incidentally, another thing, unlike volt meters, you can connect these backwards. And here's a hint. However I connected the first time, you got more than a 50-50 chance that that's the incorrect position. So we're going to try it out. Let me try it with the battery first, and we'll see. If you see the needle flick that way, it was the wrong way. Oh, it's the right way. That freaks me out. I'm going to go buy a lottery ticket. So, admittedly, this is I found this actually. This is I bet this is a 30-year-old meter that was still in the packaging from Radio Shack. I'm pretty sure it said Radio Shack at the time. Anyway, I felt the need to use it. So it's 5, 6, almost 7 amps. So I call that 6.8 amps running off the battery. And I vaguely remember this saying it was a 7 or 8 amp fan, so that's close enough. And so that's information I can use later to compare fans and such. Just out of curiosity, let's do the plug and see if we see fluctuation on the ammeter. A little bit. I saw it flip a little bit. And it is now running, from the power supply, it's running 5, 6, almost 7. So it's almost exactly the same. So about 6.8 amps. So it looks like there's not much difference. And to me, what that means is the battery is fully charged. The setting on this power supply just happens to match very closely what the battery has. And I'll tell you another hint is I had some thinner alligator clip wires, and I had lower amps, and I didn't realize how thin my original alligator clip wires were until I went to disconnect it, and it was pretty hot. So I went to 14 gauge with all my wiring, and lo and behold, my amp readings were more similar between the two different power sources, and it was actually higher. I was actually less than 5 amps with a thinner wire. So that's something to keep in mind if you do projects like this. Be sure you don't get lazy with your wiring gauge and start getting too thin. For instance, this looks kind of thin, but this came with the fan, so I can't change that.